All right, guys. So today we're going to be talking about describing the distribution of a quantitative variable. So we're going back to quantitative. We just talked about categorical today, and today we're going to take it back into that those quantitative variables, so those actual numbers, and we're going to go over how much will I really make at this company. So let's say you get hired at this company, the boss shows you all this new stats. Like, how do you determine, like, is he telling me the truth or is he using statistics to skew the script? So for your notes, we were talking about 1.7, describing distribution of a quantitative variable. Some topics that we're going to go over are measure of center and spread, and then we're also going to revisit that technology piece, like how do I find all these summary statistics in my calculator and using my calculator. So this is going to be kind of a cleanup lesson to what we did on Friday. So the very first thing we're going to talk about is measures of center. Now, one of the most popular measures of center is going to be finding the mean. And when we see the word mean, it's the average. We can see this represented a few different ways. We might see an X with a bar on top, or we might see the Greek letter mu. And mu, mu, is this little, like, it looks almost like a U, but a little tail in the front. So what the mean is, and you guys know this, it's the sum of the data values and it's divided by the number of values. So for example, I would add all these numbers up, see how many salaries there were, and I would divide them by that number. Mathematically, what we show is we say the mean, or x bar, is the sum. The sigma means sum of. Xi means each of these data points. And then n is the number, or the sample size. So let's see what that actually looks like when we're applying this formula, because you guys have technically been doing this for some time, probably since like 7th grade, but you just haven't seen it in such fancy writing. So what that really means, the sum of every single data point, right? We say 39, 34, 34, 35. We're adding all these values up, and if I were to count how many salaries there were, I would say, okay, there's 12 salaries, so that's my sample size. When I do that, I get 601 divided by 12, and I get 50.1. Make sure it is important that you guys are using context right here, especially when you're describing those summaries, that CSOCS. This is $50.1 thousand, so this is $50,000 or $50,100. We've also talked about median before, but let's just highlight how that looks. Median is the middle number, but you first have to arrange everything from least to greatest. So how I usually go about median is we start crossing off. I get everything lined up from least to greatest, and then if I cross off a 29, I cross off a 185. If I cross off a 32, I cross off a 67, and we keep on going from there. We see that the median, we stop and we get to 34 and 35. So I just find the average of those two numbers. So I just add those together and divide by 2 and get that the center of my data would be at 34.5. Again, make sure when you are describing the data that you are using appropriate context. Since this is salaries, someone did not make $39 in a year. Someone made $34,500 or $39,000, right? So we're always working back and including proper context here. So I want for you guys to think about this. We're going to talk about it later, but let's think about the fact that we looked at all these salaries. We found the mean, or the average, was $50,100, and the median was $34,500. If a boss is trying to hire you to work at this company, and she says, or they say, our typical salary is $50,100, is that misleading information? And why or why not? Think about it. I'm pulling back up a histogram that we looked at on Friday, and this is the histogram of ACT scores. So on Friday we looked and we said, okay, these are the ranges of ACT scores, and these are how many times they occur. So if I were to add some stuff on here, I would say, oh, a range of 9 to 12 occurs twice, 12 to 15 occurs 3 times, etc., etc. So the very first thing you need to do is we need to actually see, like, how do I determine exactly where the median is? Because when we looked at this on Friday, we kind of drew a little lump on it and we said, okay, it looks like the median's somewhere around 24, but like maybe we're not sure. So how we figure that out is we divide the total sample size by 2, and this will give you the location of that. So what I mean by that is we're going to add up all these values that I just wrote. So 2 plus 3 plus 5 plus 7 plus 9 plus 9 plus 8 plus 7 plus 5. And when I add all those numbers up, I get 55. This means that the middle value occurs at 27.5. So 27 to 28, somewhere between 27 and 28 numbers past my starting number. So the median is going to be the 28th data point in this scenario. So let's start counting these frequencies until we get to 28. So we're going to say we have 2, let's add 3, let's add 5, let's add 7, let's add 9. Okay, we're almost there. And then if we add 9 again, we get to 35. I know that my median is my 28th data point, so I know that it actually needs to be between 24 and 27. So on Friday when we looked at this data, we said, oh, hey, this median data point might be somewhere between, right? We said maybe it's around 24, but this is just to clarify like how actually we should have found this would be to add up all those frequencies, and this is going to be your more precise measurement. You're going to say your median is going to lie somewhere between 24 and 27. And remember, with histograms, we are talking about a range, so I can't make a guess and say, oh, our median is an ACT score of 25 or 26. I cannot say that. I have to say, oh, my median or the center ACT score is going to be, so reporting the interval, right? It's going to be between 24 and 27. Now we've talked about this before. Let's talk about some measures of spread and just clarify. So really this lesson is all about like clarifying some of these little nitty-gritty topics that they really get you. So the first measure of spread is our range. Our range is our highest minus our lowest. It is super important that we are reporting what that range is, not like 185 minus 29. So when it asks for the range of data, you don't say, oh, it's 185 minus 29, especially when we are not dealing with intervals. So for example, in histograms, our range is not going to be as precise because I don't know my truest high value or my truest low value unless it's accompanied by a table, correct? But if I just am given some sort of histogram, I'm not sure, like, is my lowest value 9 or is my lowest value 36? Or is my highest value 36? Who knows? It could be 33.2. But when I have legitimate values, I should report my range as a single number, not as a spread of two numbers. Spread is when you can say, like, oh, the spread goes from this number to this number. But when I'm asking for range, I'm saying, like, literally how far is the distance between the highest and the lowest values. Now, you've probably heard of standard deviation and maybe even been asked to calculate this before. So let's talk about like what is standard deviation. You have probably done it on your calculator but have no idea like where this number even came from. You're like, okay, this is about how far it is from the mean, and we talked about that normal distribution curve, and we were like, okay, these are one standard deviation, two standard deviations. Here, I'll find a picture. So here is that little picture right here. And remember, when we talked about standard deviation, we said, okay, usually if the curve is normal, we talked about standard deviation and like where could you kind of divide up this curve into chunks and gather most of the data, or like 99% of the data. So standard deviation is indeed distance from the mean, or distances from the mean, I should say, because standard deviation changes based on how much my data varies. So what we are going to do is we have this little guy right here. This distance is from the mean. We saw x sub I, and this just means data point, and then we're subtracting the mean from that data point. So for example, with that 185, we would say data point 185. We know the mean is 50.1. So when we subtract that, I get 134.9. We take data point 67 and subtract 50.1 and get 16.9. Keep on doing that. And what you should notice is that we are getting negative values and positive values, and these are all listed over here on my left. So when I took 29 minus 50.1, I got negative 21. 32 minus 18.1, I got, or sorry, 32 minus 50.1, I got negative 18.1. All the 34s were negative 16.1. 35 minus 50.1 was negative 15.1. So we have lots of negative numbers and then a few positive numbers. Usually this is an indicator, if you have a lot of values below and only a few above, that there is an outlier in the presence, but we can get into all that later. But essentially, like, what this is meant to do, if you think about all these values, we have lots of negatives and some really big positives. Essentially, they're going to kind of like cancel each other out. So the standard deviation is actually talking about like what is the average distance from the mean. So like how much on normally would these numbers, like how far would these normally be from the mean? Or the typical distance from the mean is what we should say. So what we're actually going to do is we're going to take all these values or all these negatives and we're going to square them, or these numbers, we're going to square them. And the reason that we square them is because we don't want those negatives to get into the way, because if I just added up all these numbers and I said, oh, my typical number, and the negatives cancel with the big positives, and I said, oh, my typical distance is 0. We know that's not true. So we need to figure out a way like, okay, how do I get rid of the fact that this value is negative but still make it count? And let's square everything. We'll talk about undoing that square later, but just note that we do square everything to undo the impact of that negative value or that positive value. And then we add them all up. So we're thinking about some math terms we might be seeing in the formula. Remember, sum is that sigma or that capital like Greek letter, that E almost. And I add up all these squares and I get 20,922.92. Now after that, we're going to divide that by the total numbers in my data set minus 1. We do not divide by just the total number, we divide by minus 1. There's a very long explanation as to why we do that. We're not going to get into that today, but know that we are not finding, that's why we like kind of modify this, like we're not finding just the average distance from the mean. We modify this to say typical, just because technically, in this case, because we have that n minus 1, it's not going to be the perfect average. So there were 12 data points, so I'm subtracting 1 and I get 11, and I get 1,902.08. Now, you're probably like, well, I know that that's not actually like what the deviation is, and here's where that square root comes in. We did square all these numbers to begin with, so we're going to square root at them at the end, and we're going to say on average, these numbers vary 43.61 or 43,610 from the mean. This is my typical distance or my standard deviation. Now you might think like, ooh, that's a really big number, and this is also an indicator. If your standard deviation is a very large number, this is an indicator that you have some outliers that are playing into effect here. Here is my formula all beautiful. You will almost never be asked to do this all by hand. You will usually be asked to do it in a calculator, which is great news, but you just need to know where it comes from. So let's kind of look at this formula. It looks a little scary and beastie. We have the square root of, right? This is sigma or sum of. Remember, xi is going to be one data point minus the mean. And then that's all over in minus 1. So if I were to go in and I were to be like, okay, let's actually like get into this, I would say that this guy right here, let's get a little pen going. I would say that this is sum of. Remember that this first guy right here is data point. This guy right here is the mean. And this right here is total number of values. And then this guy right here is going to be typical standard deviation. And this also is in that data set. The last little guy we're going to talk about is we're going to be a little bit more specific for our measures or our interquartile range. Like, how do we actually get those numbers? So the very first and most important number is going to be our median. So when I look at that, remember I split, I say, okay, we're going 25, 185, we go all the way to the center, split these values in half, and I get that my median is 34.5. From there, I keep on working, and I'm going to cross off 34, 29, 32, 34. And I'm going to see like how many numbers are to the left of the median, split those numbers in half. How many numbers are to the right of the median, split those numbers in half. So my Q1, 3 numbers below, my Q1 starts at 34. And then my Q3 starts somewhere between 39 and 43. We just literally take the average and we say my Q3 is going to end at 41. This gives us our interquartile range. So our interquartile range would be 41 minus 34, which gives us 7. So we can say our IQR, interquartile range, this means 50% of our data is 7 points away from each other. Going back to those salaries, we know that the range of the value is 156. The standard deviation, or 156,000, right? The standard deviation is 43,610, and the interquartile range is 7,000. Now, when interquartile range and standard deviation are so far distance from each other, this really does mean that we do have that those outliers, right? So I want for you guys to think about this. Which measure of spread, range, standard deviation, or IQR best represents the typical distance between salaries? So how far are these salaries typically spread between each other? And why is that measure of representation the best? So keep on thinking about this. Again, last but not least, I gave these to you guys already, but if I'm looking at these lists right here, the standard deviation, the only guy new, so remember you're going to still do stat edit, stat calc. When I get those statistics, so stat calc, and then I would go to that one variable statistic. When I get those values, I just changed that to stat calc 1 if you're taking a screenshot of this right now. This is also in your notes section, in that calculator tips. When I get that calculate and I scroll through, if I look for SX, that will give me, so here's that value right here. Let me get a nice little highlight to it. That SX, there's that standard deviation, and my calculator does all of that for me. So be thinking before we come back to class. Remember, these are two apps that you can use on your phone to get a TI-84 on your phone. But really be thinking about which measure of spread represents the typical distance between salaries and why, and would your boss be misleading to tell you that the mean or the average salary at this company is $51,000?